Okay, everyone, we're here back again, and this time we're going to go into a third series. This third series will show how we deal with beams that have a slight overhang or overhanging load. Here's a slight overhang. Here are some overhanging loads. So what we'll do is we'll explain how we got the reactions for this. Then I'll start inking up and labeling the shear diagram set and later the moment diagram set before explaining. Okay, first beam, 600 pounds. It's between the two supports in a 1-2 split. Therefore, 400 here, 200 here. Distributed load, 60 pounds per foot times a total length of 20 feet for that load. So that equals 1,200 pounds going through its centroid right here. The centroid happens to be doing also its own 1-2 split. Therefore, 800 here, 400 here, and those are the totals for this beam. Second beam with a much tighter width for the supports. We have one distributed load, 60 pounds per foot, 20 feet. So a total of 1,200 pounds squiggling through its center of gravity, which just happens to be right over a support. So everything in the 1,200 goes right here. And then a point load of 300 pounds way out here with two legs. Therefore, the inner support on the left, now only being one leg apart, now has to carry 600 downwards as a sort of countering weight to this. And because it's also going downwards, all the downs must equal all the up, and 900 goes into this reaction here, totaling 2,100. Third beam, we could have seen this as a first block that was this high and a second block that was this high. Instead, I chose to review the thing as a top block that's high with its own center of gravity here, and a longer block this way with its center of gravity here. So let's do that. Top block, 60 pounds per foot, running for 10 feet. That's 600 pounds. Happens to be right over the support. Easy 600. Then the bottom block, 60 pounds per foot also, but going for 20 feet. So that's 1,200 pounds squiggling through here its center of gravity, which is one distance apart, and therefore going to be countered by another distance apart equally for 1,200 downwards. Add those two together, that's a 2,400 here. Therefore, this reaction totals 3,000. These are our reactions, those are our loads, and so we are now done with the first step of load diagrams. We can proceed to shear diagrams next.